and the pricing concern, and the trust concern, availability issue. So problem statement, customer satisfaction for the Dabur honey is declining with the 30% of the complaints related to the packaging and 24% to the taste consistency. The goal is to reduce the complaints by the 50% in the next 6 months. So this is the caselet. In the major phase, we are going to collect the data for the last 6 months. That is monthly sales is 50,000 units. Customer complaints, the 500 complaints per month. Complaint breakdown, packaging 150, taste consistency 120, pricing 100, purity 80, availability 50%. So we'll go for the analyzing phase. This is a root cause analysis, packaging inconsistent sealing process, taste consistency variation in the honey batches due to the sourcing, pricing competitors offering similar products at a lower prices. So based on the Pareto analysis, 30% packaging plus 20% 4% taste, 54% of the total issue. Focus here is on the maximum impact. So complaint rate will be the 500 upon 50,000 multiplied 100. That is your the 1%. So based on that, this is the one complete caselet that we are going to we are discussing here with the problem statement of the Dabur and the improvement phase. We are going to go for improving the packaging, upgrading the sealing machine to ensure the consistency, taste standardized blending process across the suppliers, pricing, introduce the more miniature affordable packs. And in the control phase, we are going to monitor weekly checks on the packaging lines, feedback, monthly VOC collections, KPI track complaints rate monthly, target 0.5% complaint rate, and results complaints reduced from the 500 month to the 250 months in the 6 month. Packaging complaints are dropped by 60%, test complaints by 50%. It is another CPOC diagram defined tool, which is being also used for a high level process map. In the Six Sigma, CPOC is offered to use during the define phase of the dynamic improvement process, that we are going to map the suppliers inputs in then inputs, then process output and customers, whatever are the items which are going to be there relevant to the raw material and other material in their sequence of lead time and other things which are going to map. And based on the mapping, we are going to go for measurement and analyzing them and improvement phase and the control phase. So this is the one of the just a template that how we are going to use it. The vendor, producer, management, and customer. And this input will be the input 1, input 2, input 3, input 4, input 5. Process step 1, step 2, step 3, step 4. Output will be output 1, 2. External customer, internal customers, and there will be a if there will be some initiations of the problem associated with the step 4 to the input 2, then we are going to referring it the back. So that's how the CPOC diagrams are being defined, and we are going to analyze the based on the data and the input or and process output customers, the sequence of operation that we are going to identify. Then we are going to go for the this CPOC diagram analysis, and based on the analysis, we are going to go for the rectifications. So tools for the define phase, there is another tool that is CTQ, critical to quality, that is also identified the customer needs are connected to the specific measurable process performance matrices through the CTQ tree. It makes it easier to set up the measurable objective in the links, the improvement efforts to the customer expectations. Scenario, the Ultratech cement has been facing the delay in inconsistency supplying the cement delivery to its distributors and the construction site, impacting the project timelines and the customer satisfaction. So we are going to go step 1, identifying the VOC, in which we are going to define the 100 distributors and the contractors to understand the pain point, the key area identified, on-time delivery, order accuracy, handling and packaging, and the pricing transparency. I am going slightly faster in this because this we also discussed in the last session. The step 2 is to translate the voice of the customer into the CTQ. That on-time delivery is a delivery time, order accuracy, right quantity and the grade, handling and packaging, back integrity, pricing transparency, the pricing communication. So step 3 will be the problem statements. The Ultratech cement faces the challenge in delivering the cement on time with the correct order accuracy, minimizing the damage and improving the pricing transparency. The goal is to improve the on-time delivery from 85% to the 95% and order accuracy from 90% to the 98% in the next 6 months. Major phase, data from the last 6 months, and analyzing phase for the translation to the VOC into the CTQ. And the improvement phase, solution implementation, route optimization, order automation, bag handling, and pricing alert. So these are the necessary actions as far as the improvement phase is concerned for the defined problem. And then we are going to go there for the results. After 6 months, on-time delivery improved from 85% to 96%. Order accuracy improved. Bag damage reduced. Pricing communication reached to 100% timeliness. And this is the MCQ based questions. In the Six Sigma project, the Hyundai identified the customers' expectations for the product reliability would involve using the voice of customer. That is the correct answer. And CPOC in Reliance Geo service process improvement would help identifying the key suppliers input, processes output, and the customers. In the Amazon's warehouse optimization, mapping the value flow from product arrival to the dispatch is an example of the VCM. CTQ in big baskets delivery process would be prioritized as a on-time delivery rate. In a Mahindra product launch project, a Gantt chart is the most useful for the analyzing the process variations. So similarly, the tools for measurement phase, the process mapping, measurement analysis tool, check sheets, techniques for sampling, run charts, process capability analysis, Pareto chart, and benchmarking. This is all we have already discussed in the last session. Now I'm going for the tools for the analysis phase. This is also again a revision session. The fishbone tools, five wise analysis, scattered plot, regression analysis, root cause analysis, failure mode and effect analysis, value stream mapping analysis, the flow process. So this is the cause and effect diagram in which we are going to go the part which is going to produce the wrong with the wrong size, and we will just analyze with the whether the fault will be with the machine measurement, materials, methods, environment, and people. We are going to a small this leaves also for under the machine which are going to be expected your the points which can be taken into consideration for any of the your this part which is going produced for the wrong side, whether related to the machine measurement, material, method, environment, and people. And then we are going to identify the exact malfunctioning of the whether it is from the machine measurement, material, method, environment, and the people. So another is the 5 by analysis that we are going to go for the 5 times that why it has been happening. So that also we have discussed. The process mapping, the VSM also we have discussed, in which you are going to project the workflow visualization tool that pictorially represents the events that leads to the user receiving the product, including the product development and the supply chain, design, quality assurance, customer supports, and we are going to developing it in the industry to map the inputs and the outputs and reduce the waste. So this is how the this information flow, material flow are going to be plotted as far as the process mapping is concerned, value stream mapping is concerned. Then we are going to analyze that value added and non-value added activity. And based on the non-value added activity, if it can be reduced with that particular time delay or completely eliminated, that we are going to consider and may be eliminated also if it at all not required. So what is the value stream mapping that we are going to consider? These 8 type of your the waste, that is wetting, defect, inventory, overrun, or maybe overproduction, processing, motion, transportation, wherever it is going to be the excess that we are going to consider, and we are going to eliminate them or reduce them. So this is the another example that we have discussed in the process A, process B, process C, process C, and after that it is shipping to the customers. That is going to take 5 days, 6 days, 8 days, 5 days. That is your production lead time, and this is your processing time. So 4.2 is the value added processing time, and 95.8 is the your non-value added time that we can definitely reduce. So tools for the improvement phase, that is failure mode effect analysis, brainstorming, affinity diagram, cause and effect diagram, PUG diagram, design for experiment, pilot testing, and root cause corrective actions. So this is the one example for the tools for the improvement phase. That is your affinity diagram, and this is the MCQ based questions. And that also I think we have already discussed in the Six Sigma project for the Hyundai. Identifying the customer expectations for the product reliability would involve using the voice of customer. CPOC in the Reliance Jio service process improvement would help the identifying the key supplier inputs, process, output, and the customers. CTQ critical to the quality in the big basket delivery process would be prioritized. On-time delivery rate in Ola vehicle maintenance processes check sheets would help track the frequency of the vehicle breakdown types. Compare the hospital patient discharge time with the global standard. The tool applied is the benchmarking. Now coming to the next topic, that is for the module 7, the learning objective is the what are the different type of phases in the principles of the DFSS design for Six Sigma, and applying the DFSS tools and techniques for the innovations. Now, the design for Six Sigma is also known as DMADV, that is recognized as a design for Six Sigma methodology, and acronyms for the define, measure, analyze, design, and validate. Normally, DMADV is used for the initiation of the project or initiation of the product development, initiation of the any system development, and DEMIC is used whenever there is a problem in the existing system, in the existing operational system. Now there is a two another terminology, that is DMADV and DMADOV. So O also stand for the optimize. So DMADV force attention to on the need of the optimizing the design. Additional tool useful in the phase includes the design for experiment, response to the surface methodology, and evaluation of the operations. These methods help in design team establishing the refined design parameters. Now, design for Six Sigma is an acronym that stand for the define, that is define the project goals, including the customer focus. Again, the same customer requirement to use market forecast and the competitor analysis, create the project charter for a new plan. So design for Six Sigma used for the new projects, new development, new product development features, and maybe new innovations, maybe some radical change in the product or services or any systems. Then we are going to use the DMADV, that is design for Six Sigma. Then measure the opportunity, determine and rank the customer needs, use the intervened survey for the CTQ, and benchmarking opportunity, determine the creative solutions. Then we are going to go for the analyze phase, that is select the best, is discuss, use some affinity diagram, brainstorming, and examine options. And the design phase, again, we are going to develop the product and processes, design experiment to verify the design meet the customer needs. That is the for the new product development and new systems development, new services design, like in the hotel industry, which you are going to design the since beginning, establishing the any hospital, establishing the new systems, new and new mall, maybe the D Mart, which is establishing a new in the new city, any another retail chain. Then we are going to go for the design Six Sigma. What are the previous radical problems which we are going to analyzing, and we are going to mitigating in that particular, you are the new development or the new extension of that particular mall in the another city, or maybe a new product development, or maybe a product which is being developed and there is a radical change in that particular product which are going to be there. So design for Six Sigma is in the another way, another type of your the Six Sigma process in which you are going for the new product development, innovations, or maybe some radical changes in the some parts which have already been developed, or maybe some systems, some services. And as far as the dynamic is concerned, that is in the existing system, if there will be small changes, small problems which are going to be arriving. So on a continuous improvement basis, you are going to use the dynamic. Then optimizing, evaluating the performance levels and the impact, and then verifying the process ability to meet the customer needs and deploy the new processes. So in the design phase, that we are going to definitely meet, trying to meet the customer needs, and possible design tools will the QFD matrix, FEMA, failure mode effect analysis, brainstorming, Tagachi robust design, and design for X. So these are the some of the tools which we are going to discuss it here in the what will the in the design phase as far as the design for Six Sigma is concerned, or maybe it is basically the DMA DB phase. That is we are going to discuss. Now, as far as the design phase is concerned for the DMA DB in the system design, there is a three stage as far as the system design is concerned, or maybe like a one Xerox machine is there. Then we are going to see there are small systems that Xeroxing that taken out of the print and stacking of those particular print, maybe that machining process of that your Xeroxing. So this is we called a small. So complete Xerox machine will be system design. So then under the system design, there will be some components of the characteristics or maybe subsystems. So system is an interrelated set of the components with identify the boundaries for some purpose. So boundaries will be that one system for putting the paper into a Xerox machine. So that is the one small system. Again, there will be a system of Xeroxing that is going for the processing. Another will be taken out of your paper after that particular Xeroxing. So this is the we can majorly define the three subsystems in which that one complete system is a Xeroxing of that copying copier machine. It is being designed. So system has a different characteristic. It can have a component subsystems. Interrelated components. A boundary means the one subsystem which is overlapping to the another. So there will be a boundary, a purpose, the environment, interface, input and output, and some constraint. That suppose we cannot put the maximum more number of the pages simultaneously into the copier machine. So there will be some constraint. Similarly, there will be output which is going to come. That output the number of sets. If we are going to put in that number of sets could not be met, that we are going to go for the manual process. Input also that we can go for the sequencing of that number of Xerox, this copying the items. So system characteristics will be a component is in the item or the part which is going to be a part of the subsystem or the system. Interrelated component dependent on the one subsystem. Boundary will be the line, the marks that inside and outside of the system that is defining the one system to the one system from the another system. Send logical system descriptions or descriptions of the system that focuses on the system functions and the purpose without regard to how the system will physically be implemented. Say like in the automobile also that we are going to your starting system, the fuel injection systems. Then we are going to go for the ignition system. Then we are going to lightning system. Then maybe burning of the fuel. Then converting it into the power. So these are the some logical system which is giving the one to end the another that indications. That's why the automobile it is going to work completely as a single system. So there will be physical system description and the logical system. So logical system will also provide the indications to the another system where the inputs are going to be used for the your outputs. So that is how the description of the system that focuses on the how the system will be mutually constructed. And decomposition. It is a process of breaking down a system into a smaller components or the order to focus on the one area at a time, concentrate one component pertinent to the one group of the user, build different component at the interdependent times. Now we are also going to divide the system into a chunks or the modules of the relative uniform size to simplify the redesign and the rebuild process and coupling the extent to which subsystems depend on the each other. Subsystems should be independent as possible. If one subsystem fails in the other subsystem are highly dependent on it, then the other will either fail themselves or the have problem functioning. So that is coupling that we are going to use in the motor and the pump also. There is a coupling we are using. So motor will drive the pumps. So the coupling will instead of damaging the pump and the motor, both connected with the shaft. So there will be a coupling. So prior to the some damage or some this damaging to the shaft and others, the component of any motor, the pump, the coupling, the rubber pads or the coupling, the flexible pads are going to be started damaging. So there will be very less costly affairs which we are going to modify them. So that is in the design phase that we are going to consider that how the coupling can also be designed in such a way so that it can reduce that type of those particular failure. So introducing the designs for Six Sigma. So focuses on the objectives is focus on the creating the robust design to minimize the variability in defects, ensuring the high performance, aim for the customer satisfaction by aligning the design processes with the voice of customers. So why DFSS? The traditional Six Sigma focuses on improving the existing process. DFSS proactively designed for the new process and the products to prevent the defects rather than the correcting them later. And key principles: understanding the customer needs, translate these needs into a design specification, optimizing the design to ensure the performance, reliability, and the quality. So DFS methodology is define, measure, analyze, define, and verify, and identify, design, optimize, and validate. So these are the two acronyms for the DFSS. So need for extending the Six Sigma principles to the design phase for a successful project or the product manufacturing procedure. It is essential to apply the Six Sigma uh, concept to the design phase as described in the design for Six Sigma methodology. This proactive strategy seeks to create high quality, dependable, and client satisfaction systems for the goods and services. The main objective of the traditional Six Sigma is to find and fix flaws in the current processes. DFSS, on the other hand, is concerned with the stopping the problems before they start. Potential cause of the defects are identified and eliminated before they influence the finished product or the processes by implementing the Six Sigma concept during the design phase. So correcting the mistakes and flaws after a product has been produced might be sustainably more expensive than doing it before. Changing a product design is typically less costly and the disruptive than the redesigning and recalling it again been after the production and sold. So that's our need for extending the Six Sigma principles to the design phase is no secret that redesigning an existing product to meet the customer needs better is expensive and wasteful. The time and effort it takes to test and develop multiple iterations on the same product before reintroducing it to the market is valuable time that is you could have spent elsewhere had the product met the customer's expectation and had the high level of the quality for from the starts. So design for Six Sigma objectives to additional work today to ensure that there won't be any rework tomorrow, fully aligning a design with your customer's need and expectations before the designing completion significantly decreases the chances of the correcting defects in the issue after the implementation. So DFSS, the new product development, that is discovery, design and develop, test and launch, useful product lifespan, that is solve the quality issue, solve the reliability issue, solve the durability issue. So this is once the product is already been launched during the useful life of the product that we are going to go with the smallest of the problems in the process, in the system, in the product, in the quality are related and defects, number of defects related. So those we are going to correcting under the use of that practice of the Six Sigma. That is the DAMIC. And DFSS we are using the for the new product development. That is a discovery, design, development, test, and launch. So basically, we are going to go for the either it is there will be a continuous problem, then we are going to for the radical change as far as the product is concerned, services are concerned, or else we are going to define it with the starting that is your design for the new product development stage, or maybe services as well. So introducing the DMAB, these modules are the companion to the project. And the Lean Six Sigma uses the DMIC method, whereas the DFSA uses the DMADB. So DMADB is used to improve the existing process, but sometimes the process does not exist, and you may need to create perhaps the new service and the new product. Now we are going to just go with the some of the examples in the methodology, DFSS methodology and phases. I just skip the two three this the PPT sheets from the deck. So that's are basically the understanding of the DFSS and with the some other examples that we already been discussed. So I'm just switching over to the DFSS methodology and their phases. So again, the phases will be the define phase, measure phase, analyze. Again, that is the design phase and verify phase. So design will start after we are going to defining, measuring, and analyzing the existing your product situation, your reliability considerations, your innovations in the system, in the processes, in the product or in the services. So design for Six Sigma is a customer-centric approach, emphasizing the meeting the customer needs and the requirement while minimizing the defects and variation. It strives to achieve the highest level of the quality in the design phase itself, leading by significant cost saving and the customer satisfaction by integrating the principles of the Six Sigma into the design process. So that's how it is going to be there. So define phase is the first step, that is to define the customer requirement, translate them into the clear, measurable design objective, understanding the customer needs, preferences, and expectations. Major phase is the data collection to establish the baseline performance and evaluate the existing process capabilities. And analyzing phase that during statistical tools and the techniques are employed to identify the critical factors influencing the design performance. In the further the design phase, the involving that involve the concept creating the prototype and refining the design based on the customer requirement and data analysis. Robust design methodology ensures the design is reliable or not. Then we are going to go for the manufacturing meeting the all specifications. Verifying the design is thoroughly tested and validated against the established targets and the requirements in the verification phase. This step ensures that the design performance are intended as it is going to meeting the quality standards and the requirements. Now, under the design phase, the tools which are going to be used for the this DMA DV, that is your voice of customer, critical to quality and quality function development. We are going to discuss each of them and with an example, one of them. The project scope goals and the client requirements are all the determined at the initial stage. That to comprehend the client wants, the voice of the customer analysis is being used, often and analyzing the client inputs to the better understanding their wants and expectations known as the voice of the customer. Critical to the quality flow down, the transforming high level client needs into the precise quantifiable qualities that can be addressed throughout the design process is called the critical to the quality flow down. Quality function development is another tool of in the design phase. The creating a matrix that connects the customers, so the consumer demands with the product and the process characteristics to goal to the quality function development strategy, which uses the structure to translate the customer wants into design features and the process requirements. Now, why implement the quality function development? Because it is a customer focused. It will give the voice of customer analysis and shorter deployment time and the lower cost and structured and documented. So we are going to go with that in detail with the one example, that is structure of the house of quality. That is your the we are going to develop the quality function development. So in which it is on the left hand side that the customer voice words it is going to be noted down. Then derivatives we are going to provide it here, and we are going to go with the product attributes here A, B, C, D, E based on that what and weightage. And we are going to go how these are going to be converted into the engineering. So their corresponding relationship are going to be taken into consideration, whether it is the in relation with that, in correlation with that, or not in the non-correlation with that. Then competitive assessment are going to be taken into consideration with our product and with the competitor A and B. Now, based on that data, we are going to go for the importance weight, relative weight analysis. Basis the relative weight importance, we are going to consider which particular parameter it is going to be a very important as far as that your structure of the house of quality and the customer voice is concerned. So basis, we are going to just go for analyzing them. So we are going to just discuss with this. This is a template that we are going to discuss with the one example. So suppose there is a chocolate bar, then we are going to plot the voice of the customer in the left mode of the grid of the house of quality, providing the importance rating weightage to the each factor, the grade test, the attractive appearance, low price, and relative humidity. So we are going to give the their weightage 5, 3, 4, 1, and based on that, our products will be this is the rating, the competitors A rating, competitors B rating that we are going to consider the taken into from the market, or maybe competitors itself. It can be easily available. Then we are going to go for the house. That is the based on the flavor, packaging, sugar content, size, and quality of the milk. These are the some considerable parameters which are going to consider under the voice of customers. So if there will be a great taste, then we are going to go for the flavor. That is your highest requirement. That we are going to the 9 marks. Then packaging will be the greatest. It is a non-relevant, so it is a 0. Sugar content, it is a medium, so it is a 3. So 0, 3, 9. Normally these are the 2, 3 in the sequence that we are going to put in marking as far as the marks are concerned. Then attractive packaging, then again it is flavor, it is non-relevant, so it is 0. Attractive packaging, then packaging it is 9, rest of them are 0. Low pricing, the flavor, based on the flavor it is non-relevant, but based on the packaging it is the medium. Then if it is a size, then low price will be your relevant, and quality of milk is the medium relevant. And relatively the healthier as far as the flavor is concerned, packaging is concerned, sugar content is concerned, size is concerned, quality of milk is concerned. So based on that, we are going to develop that your the matrices. Now, as far as the house is concerned, that we are going to go with the like flavor with the packaging. So there is no relation. So we are going to put at 0. Now, flavor with the sugar content, it is a positive correlation. So we are going to put a the plus sign. Flavor with the size, that it is no correlation. So we are going to put a 0. Flavor with the quality of milk, it is a very high correlation. So that we are going to put a double plus. Similarly, rest of them we are going to put that your the matrices for as far as the house is concerned. So how is basically nothing but how we are going to consider while putting these particular your parameters into the engineering. So if there will be a very significant correlation, then we are going to consider that parameter with reference to the same. If it is a non-significant, that we are not going to concern more. So basis that we are going to go the target value, actual value, competitor A, competitor B, based on the each of them, and then we are going to calculate the weightage also. So importance weight we are going to calculate. So it will be like weightage and sugar content, it is 24. Similarly, the importance weight will be the 45 for the first, then 24, 36, 60. We are going to make a total. Then relative important weight that we are going to go 45.204. So it will be 22.05%, 19.11, 11.76, 17.64, and 29.41. So whatever is the minimum, the percentage will be there that we are going to just consider first, because that is a very relative important. So importance weight as far as the in our product is concerned. But whatever the highest percentage there that we are going to concern, that this should be, we have to improve upon the relative importance weight. So this is the first aspect as far as the defined phase is concerned for the design for Six Sigma. Now coming to the measurement phase. So under the measurement phase, collection of the data and evaluation of the baseline performance. So we are going to have two tools, that is your measurement system analysis, process capability analysis. So measurement system analysis assuring the accurate and reliable measurement method, avoiding the errors that might produce the enormous results. And process capability analysis, evaluating the ability of the current or proposed procedure to meet the client demand. So introducing the measurement phase, process capability overview. The process capability is simply the ratio of the spread of the process data is shown in the figure, comparison of that to the spread of the specifications of the that process. It is a measure of the how well the spread of the data fit within their specifications range. So a process said to be capable when the spread of the data is contained within the specification spread. So it is a mean value, and this is allowable lower spread and allowable upper spread as far as the this normal distribution pattern is concerned. So this is with the mean value. The blue line, it is up to the mean value, and this is your process spread with that your the orange color, and with the green color upper process spread, the specification range. So this is the process spread, and that is your specification spread. So that is your the black line. So now this is your process spread, and this is your the less capable with the your sorry process spread. This is specification spread, and this is more capable. That is your the blue line. That is your the allowable sorry that is your the mean value apart from the mean value on the both side. So this is the your process spread and specification spread. So based on that we are going to, if this narrow down that your other normal distribution curve, then better it is as far as the specification range is concerned. So lower the specification range, then better will be the capability of the your process. So if you just go for measuring the sum through the statistical formula, then CP will be your process capability specification spread over the divided by the process spread, that is your 6 sigma USL minus LSL divided by 6 sigma. CPK, the process capability index, will be minimum of CPL or CPU. So CPL will be allowable lower spread upon lower process spread, allowable upper spread and upper spread upper process spread. So if that is a homogeneous your normal distribution curve in the both sides, the CPL value or CPU value will be the same. Otherwise, the CPL value or CPU value will be varying if there will be skew nature in that particular normal distribution curve. So CPK value will be the minimum of them we are going to consider as a process capability index. So this is the measurement phase as far as the process capability overview is concerned in the statistical method that we are going to take into consideration. Now example showing the calculation of the process capability index, that is your centered process. The CP value will be LSL is given, USL is given, mean value is given, the sigma value is given. So CP will be the 175 minus LSL 25 6 into sigma 1.67. CPL will be 100, mean value will be 100 minus 25 3 into sigma. We are considering one side, so it is a 3. And CPU will be the 175 minus 100 and 3 into 15 1.67. So CPK will be minimum of that. So this normal distribution curve is very uniform, so it is coming 1.67 both side. Now off-centered process, that USL, LSL and the mean and sigma, then CP will be the 1.67, CPL will be 1.33, CP will be 2, so minimum of that is your 1.33. So if it is off center, then the value will be CPK will be the minimum of the CPU and CPL. That's how it is we are going to consider. Now, if what is the significance of this process capability? If the CP will be less than 1, then the process is unacceptable and not capable. So we have to find out what is the system problem, or what is the process problem, what is the product problem. And if it is in between the 1 point and 1.33, then we are going to accepting it as a fair. 1.33 and 1.66, then it is in the acceptable range. So process capability 1.66 and less than 2, then it is exceptional. So process is very wonderfully working, and CP will be 2, then good for the 6 sigma, goal to the 6 sigma. So that's how it is going to be there, that we are going to analyze. So CP will be the specified spread upon the process spread, USL minus LSL and 6 sigma. CPK will be the minimum of CPL upon CPU, CPL and CPU. CPL will be allowable lower spread and lower process spread, allowable upper spread and lower, upper process spread. Now coming to at the analyzing phase, identifying the critical factors influence the design performance. So failure mode effect analysis is the one of the tool that we are going to use, root cause analysis and statistical analysis. So the failure mode effect analysis stand for the failure mode and the consequences analysis. It identifies and rank the probable failure mode in the design and the processes that determines their cause and consequences. Root cause analysis investigates the fundamental cause of the problem and the fault to solve them at the root. The statistical analysis utilizing the statistical method to spot trends, correlation in the quality influencing variables. We are going to discuss with the example, what is the failure mode effect analysis. The concept of failure mode effect analysis is a step-by-step approach for identifying all possible failures in the design, a manufacture or the assembly process or the product service. Failure mode means the ways, modes, and which something might fail. Failure mode effect analysis, the potential failure that we have to identify, what will the mode types, weighs the possibilities, and what will the effect of that negative effect on the process under the study. Then study the risk and the ready, reduce it, analyzing what can go wrong in your the process and the or the product. Just a minute. So some corresponding definitions which we are going to discuss right now. That is failure, the loss of an intended function of a device under the stated conditions. That is your failure, the loss of an intended function of a device under the stated conditions. Failure mode will be the manner by which a failure is observed. It is generally describes the way of the failure occurs. And the failure effect will be the immediate consequences of a failure on the operations, functions, or the functionality or state of the some item. So these are the three fundamental concepts that we have to understand while going for the example under the FEMA, that is failure mode effect analysis. So this is the loss of an intended function of a device under the stated conditions, that is your failure. Failure mode will the manner by which a failure is observed is generally described the way the failure occurs. The failure effect will be the immediate consequences of a failure of an operation, function, or the functionality or the status of the sum of the items. Then failure cause will be the defect in the design, then processes, quality, or the part application, which are underlying cause of the failure or which initiate a process which leads to the failure. These are the four terminologies which you are going to definitely conceptually understand while going for the your one of the example under the failure mode effect analysis. So now there are the some terminology used in the FEMA, that is severity and assessment of how profound the failure effect will be there due to the failure mode. That is to the customer, that is your severity. If any equipment or some items which will fail, like geyser in the your this bathroom, if it is going to fail, then what will the this severity and occurrence and assessment to the likelihood that a particular cause will happen that result in the failure mode. And the detection will be an assessment of the likelihood that the current control will detect the cause of the failure mode or the failure mode itself should it occur, thus preventing the failure effect from the reaching your customers. Customer in this case could be the next operations, subsequent operations, or the end users. The risk priority number is being calculated based on the severity, occurrence, and the detection. So it will be S into multiplied by O and D. So RPN play an important part in the choice of the action against the failure mode. What will the risk priority number? If there will be two, three observations for the your failure mode analysis, then we are going to just check with the RPN number. Wherever the RPN number will be high, that your cause will be taken into consideration first, and that will be uh, attended, or maybe it is going to be improved. So FEMA type, FEMA can be for a system, then design or the construction processes, services, software. System will be focused on the global functions. Design will be focused on the components and the subsystems. Processor will focus on the manufacturing and the assembly process. Service will be focused on the service functions. Software will be focused on the software functions. If there will be equipment time, valve normally opens, the fails to open, fail to close when required, close unexpectedly, leaks to the external environment, valve body rupture, pumps normally in operations, fails on stopping unexpectedly, seal leakage, pump causing leakage, some ruptured, and heat exchanger, high pressure tube side, leak, rupture, and tube side plugged or shell side plugged. So these are the some examples for the failure mode as far as some example of the equipments are concerned. So why to perform the failure mode and effect analysis? First is the prevention of the cost. That is one. The corrective actions, if you are going to take, it is going to be 10. Failure cost will be your 10, 100. So it will be prevention cost will be one time, correction cost will be 10 times. If you are attending the failure cost for the same product again and again, and we are not revising its design or design for Six Sigma, any analysis, then it is the failure cost will be the 100 times. So FEMA will, it is going to go with the if found at the start of the journey, then it will be $1. Then if it is found in the middle of the journey, then it is $10. If it is very late, then found it is in the end, then it is $100. So benefits of discovering the failure early in the product development using the FEMA, that is going to benefit in the preventing of your the unnecessarily the failure cost and multiple choice for the mitigating the risk. Now RCM technique, cause and effect diagram, that is another the fishbone diagram developed by the Koro Ishikawa in 1943. It is also known by them name Ishikawa diagram or the fishbone diagram. These diagrams help represent the relationship between the effect and the potential or the possible causes and influence it. The cause and effect diagram in investigation tool, these are also called the Ishikawa diagram because its shape. Diagram is also termed as a fishbone diagram. There is a systematic arrangement of all the possible causes which give the rise to the effect of the in the Ishikawa diagram. Before taking up the problem for a detailed study, it is necessary to list down all the possible causes through the brainstorming session so that no important cause is missed. The cause are then divided into the major sources or the variables. So this is the one root cause analysis for the manufacturing the poor quality product. So we are going to have in the horizontal axis, then the effect will be there. Now, basis effect the poor quality product, whether it is some management problem, whether it is a raw material problem, whether it is working condition problem, whether it is technology of the machine or the manufacturing or some machine or the workers. Now, for each of them, we are going to go with the sub branches or maybe it is your sub wings as far as the fishbone is concerned. So, basic and auxiliary material is a problem, or under which the immediators is the problem, or whether it is a job accommodation problem or equipment problem, or there is some facilities problem, the tools problem. Raw material, where is the some moisture content, it is there. In the strength problem is there, storage conditions problem is there, and it is impurities, shelf life and delivery times are concerned. Working condition, it is if it is noise, humidity, temperature, or illumination is concerned. Whether it is a technology, that is availability tool is concerned, compliance technology is concerned, quality of the parts coming from the previous operations is concerned, or operating conditions, machine wear is concerned, machine type is concerned. Then there will be some fatigue is concerned, workers, then education level is concerned, then concentration behavior at the work is concerned. So these are the subsets also we are going to noting it down, and then basis brainstorming and analyzing that we are going to find out the some what are those different alternatives which can give us this particular problem of the poor quality product. So that's how it is going to be. We are going to go as far as the this uh, DMA DB is concerned. So this measurement phase is concerned. Then fourth phase, the design phase, that is refining the design based on the customer requirement, the data analysis. So we are going to go for the design of experiment and robust design. So there are these two tools we are going to use. So there are different tools, but these are the two important way of conducting the define design phase is redesigning the design based on the customer requirement data analysis. So design of experiment is a branch of applied statistics that deals with the planning, conducting, analyzing, and interpreting controlled test to evaluate the factors that control the value of a parameter or group parameters. DO is a powerful data collection and the analysis tool that can be used in various experimental situations. Multiple input factors can be manipulated, determining their effects on the desired output. By exploiting various inputs simultaneously, DOE can identify essential interactions that may be missed when experimenting with one factor at a time. All possible combinations can be investigated full factorial, or only a portion of that can also a possible combination. A well-performed experiment may provide the answers to the such questions. What are the key factors in the process? At what setting would the process deliver the acceptable performance? At what the key main interactions effect in the process? And what are the settings would bring about less variations in the output? So that is one of the in the design phase. Jenichi Tagachi is also given the robust design factor. So that is we are going to discuss. Is an engineer and statistician. Tagachi developed a methodology for applying the statistical to improve the quality manufacturing goods. Tagachi methods have been controversial among the some of the controversial Western statisticians, but others have accepted many of the concepts introduced by him as a valid extension to the body of the knowledge. So Jenichi Tagachi is given the two concepts. One is the total loss function, another is the robust design. Under the total loss function, defined quality as loss imparted to the society from the time product is shipped. Like a construction of a flyover bridge with a lower grade of material like cement and others. So cement, once it is of a lower grade and if it is shipped and being used in in the another purpose in the society, then that is also going to have a of a lower grade. So it is we called as a the addition of the your degraded quality products in the supply chain. So that is we called as your total loss function to the society. Then another will be the robust design that the noise factors which are taken into account to ensure the system functionality uh, functions correctly. Noise factors are uncontrollable variables that can cause significant variability in the process of the product. So so it will be having there are four examples we can consider: harmful side effect, failure to meet the customer requirements, failure to meet the ideal performance, and loss due to the production. Example, project flyover bridge construction, raw material supply was improper, quality cement and steel. Construction was not adequate due to the same. Constructed bridge is not having the longer life and may fail. Bridge will be needed more maintenance in the short run. So these are the impact of that total loss functions as far as the societal loss is concerned. Example two is the production of the large vinyl covers to protect the materials from the elements. So this production of a large vinyl covers to protect the materials from the elements in the your farm area. So total loss function will be the producer's loss with the plus the customer's loss. So there are three your normal distribution curve that we can just consider. This is your upper your control limit and your this is a lower control limit. Then these are the one your type of nature of your normal distribution pattern for that production of the large vinyl covers. This is the another this normal distribution curve and this is another. So if we just go with the first one, the this is total loss is the production loss, producer's loss and the customer loss. The process is just capable of meeting the specifications variations from the LSL to USL. So that is there. By effort, the production process is improved by reducing the variability as far as the graph number two is concerned. The third one, if there affect to reduce the production cost, organization decided to shift the target to LSL. So this has been shifted to the LSL means the low density your the polyvinyl this material sheets will be produced, though it is going to put an impact on the farmers that it will give the while keeping it on the in the before just rainy season or the to keep it protected from the flies in the field once that material is already been plugged in. So that's how this PVC vinyl sheets are going to be maybe torn out from the some of the places, and that's how it is going to put an impact. And this your this materials are going to be spoiled over a period of time. So that's it is going to put an impact to the society. The covers are being being used by the farmers to protect the wheat from the elements. They torn and the substantial loss occurs to the farmers. This also result in the increase in the cost of the wheat as a result of the supply demand factors and thereby causing an increased price of the wheat and the loss to the society. So that is another example. So another concept which has been given by that your Jenichi Tagachi, that is the concept of the robust design. So under the robust design that we are going to go in the first the system design. This is design of the conceptual level involving the creativity and the innovation, initial setting of the product and process parameters. Then second level will the each subsystem having the parameter design, that is nominal values of the design and the various parameters needs to be set. And then based on the each subsystem, we are going to go with the tolerance design. The resources can be focused on the reducing and controlling the variation in the critical few dimensions. So there will be three-step design process as far as the robust design is concerned. That is first will the system design, then boundary design of the subsystem. Based on that, the parameter design, and under each parameter, we are going to go for the tolerance design. But this tolerance design is it will be in reference to the other parameters also. So this is going to function as a single system, that is we call as your system design. Now industry based examples from the Genichi Tagachi quality concept for elimination of the chances of the different generations. One of the compressor design for the plant use. So development of the paper feeder for the Xerox machine, flexible manufacturing system, boiler design and the manufacturing. So these are the some examples of the robust design where the robust design is going to be applicable, like development of the paper feeder for the Xerox machine. Because in the Xerox machine or in the copier machine, that each boundary of a subsystem, it is very in the close vicinity, and we are going to have a very close impact if it is going to be one system. If it is going to be subsystem, it is going to be felt. And similarly, in the flexible manufacturing system, it is having the one system, one subsystem to the another system, which is going to be very corresponding for that particular nature of the different stages operations. And based on these operations, it is going to be put in very good impact if the flexible manufacturing systems robust design if it is failed. Then boiler design and manufacturing is very crucial as far as there are so many subsystems in the boiler, and each of them are with a very specific boundary. However, they are going to be very well connected to each of them. And the one parameter of that disturbance in any of the subsystem, it is going to put an impact on the another subsystem and the completely for the complete system as well. And maybe the boilers due to that sometimes it is going to fail and it is not providing that particular quality of that your steam services which are going to be required. And compressor design for the plant use, because compressor is also having the so many of the subsystems. That's why it is a very robust design which is going to be taken into consideration with the very defined parameters for each subsystems as well as the complete system. Now in the design phase, the redefining the design, that is by the design of experience robust design. So when to use DOE, now that is another approach when more than one input factor is suspected the influencing and an output. For example, it may be desirable to understand the effect of the temperature and the pressure on the strength of the glue bond. If we are using the glue bond, then we are going to just put an impact, that is temperature and pressure. So DOE can also be used to confirm suspected input-output relationship and to develop predictive and equations suitable for the performing what-if analysis. And design for experiment template and example we are going to discuss. Like acquiring the complete understanding of the input and the output being investigated, process flow chart or the process map can be helpful and consulted. Determine the appropriate measure for the output. A variable measure is preferable. Attribute measure should be avoided. Ensure the measurement system is stable and the repeatable. And create a design matrix for the factors being investigated. The design matrix will show all the possible combination of high and low level for the each input factors. These high and low level can be coded as a +1, and the example of the 2 minus factors experiment will require for 4 experiment runs. Now in the design phase, defining the design phase based on the customer requirement, the data analysis. Experiment number one, input level A is minus one, input level B minus one, experiment two minus one plus one, then plus one minus one, and experiment four plus one and plus one. So required number of experiment runs can be calculated using the formula. Second, n when n is the number of factors for each input, determine the extreme how and low level you wish to investigate. In some cases, the extreme level may be beyond that what is currently it is in use. The extreme levels selected should be realistic, not absurd. And for example, there is a temperature 100 degrees centigrade, pressure will be 50 psig, and temperature will be 200 degrees. Then psi will be required for the 100. So experiment 1, 2, 3, and 4. So temperature will be 100, 100, 200, 200. Pressure will be 50, 100, 50, and 100. Strength will be 21, 42, 51, and 57. Now we are going to calculate the effect of the factor by averaging the data collected in the low level and subtracting it from the average of the data collected at the high level. For example, effect the temperature on the strength 51 plus 57 divided by 2 minus 21 plus 52 divided by 2. So effect of, so it also involves your the bottommost rank. Effect of pressure on the strength 45 plus 52 divided by 2 minus 21 minus plus 51 divided by 2, 13.5 lbs. The interaction between the two factors can be calculated in the same fashion. First, the design matrix must be amended to show the high and low levels of the interaction. The levels can be calculated by multiplying the coded V levels with the input filter acting in the interaction. For example, experiment 1, 2, 3, 4, level A minus 1 plus 1 plus 1, level 2 minus 1 plus 1 minus 1 and plus 1, and interaction will be 1, 1 and minus 1. So calculate the effect of the interaction A is before effect of the interaction on the strength. 21 plus 57 divided by 2 minus 42 divided by 51 divided by 2. So minus 7.5 lbs. So experiment data can be plotted in the 3D diagram as well. So TOE analysis, the negative effect of the interaction is most easily seen when the pressure is set to 50% psi and temperature is set 100 degrees centigrade. Keeping the temperature at 200 degrees centigrade and will avoid the negative effect of the interaction and help ensures to the glue bond. Okay, we'll go for the quickly to the exercise. Design for Six Sigma is a methodology primarily focusing on minimizing the customer satisfaction, implementing the lean principle into the existing process, creating the new product or the process with the high quality and the minimal defects. C is the correct answer. First is C. Sorry, first is continuous process improvement. That is A is the correct answer. Which of the following is not a phase in the DFSS methodology? Define is there, measure is there, improve is there, analyze phase is there. So D is the correct answer. Which of the following is the key concept in DFSS that emphasizes preventing defect rather than detecting and correcting them? So it is the failure mode effect analysis. The first step in the DFSS process is to define the customer requirement and the project goals, measure the correct process performance, analyze the root cause analysis, and implement the improvement and the control measures. That is, define the customer requirement, the project goals. What is the primary purpose of conducting a voice of customer analysis in DFSS? To understand the customer need and expectations. So I'm just keeping for a minute on that slide, so you can just go through it. So So with this, our session outcome, division of the third session, that dynamic implementation process steps, defining major analysis, improve and controlling that we have discussed. And there is a difference between the dynamic and DMA/DV, the framework of the improvement process that we have discussed. Dynamic will be basically the defined major analysis, improvement control is being used for the existing system that we are going to is in the operational, and there will be some improvement where it is going to be required based on the some reliability problem, based on the some innovative problem, based on the some process capacity problem, based on the some customers a small improvement segment it is going to be required, based on the some supply chain problem, based on some distribution system problem. So that dynamic it is going to be used. DMA/DV is the design and verification that is at the last. So that is being used for the complete revamping of any system, or maybe it is from the sense design stage that we are going to use for development process of any new product development, or maybe a product which is going to be having the radical change, maybe some system, maybe some your the extension of any your system which is needing with an improvement in the process that we have discussed. Then we are going to have some case study on the dynamic and the DUADV. The some uh, questions, MCQ based and others, which we have discussed. Any questions there? So this is the module number 7 that we have discussed, in which we have discussed about the your some processes, DM and DV. So that is DMA DV is well recognized design for Six Sigma methodology and acronyms for the define, measure, analyze, design and validate. The basic difference will be the DMA DV, and DMA DOV is that O for the optimizing and has been added. Some of the other examples which we can also discuss in this regard, that is the every 6 months that we are going to see that there is a some of the mobile which is coming with that definitely functionality changing, and some of the very defined some the functions which are going to be added into that the same manufacturer, like maybe your Samsung and others which are going to be there. And in the DMart also, we can visualize that there will be a, if they are going to have some extension, then they are going to go with the some of the necessary changes which are going to be, they are observing the problems in the existing one, but it is at a radical change, not a small change in the existing the mall that we are going to go with that. That is your DMA. It is for the dynamic process. But if it is a design for Six Sigma, then it is a DMA DB. So it is going to be taken into consideration while we are going for the radical change. And similarly, if we are going to go for the manufacturing of a new copier machine, then we are going to make necessary changes with reference to the capacity, with reference to the your faster speed and other things. Then it is a DMA DB based on the customer requirement. And similarly, if we'll go for the say some two-wheeler automobile, this vehicles, then there will be a say automatic gear controlled vehicles, especially the TVS and others that we are going to taken into consideration that they are going to be put the examples of the DMA DV. After the say gear based the Bajaj scooters and others was there, the based on the customer demand and the requirement, they have been regulated with the radical change, and that have been come into the market. Similarly, if you are going with the some of the other examples that in the automobile four vehicle, the passenger cars, then there will be some steering systems that are going to be flexible with that particular your the seats and the height of a person who are going to on the driving seat, that can be modified, and that having the flexibility as far as the vertical movement is concerned, side movement is concerned, or the horizontal movement is concerned, or angle is concerned. So that is the another aspect of a DMA DB that has been implemented as far as the customer customer's requirement is concerned. And similarly, if you are going to go for the modular kitchens, which are going to be also a current demand, then DMA DB is basically a approach that has been taken into consideration. That modular kitchens are one of the good example as far as the DMA DB design for Six Sigma is concerned. Based on the customers, the sizing of this modular kitchen can be designed as a standard practice. The standard, the cabinets will be there will be the same. However, that can be redesigned based on the sizing, and these can also be optimized if there will be some of the problems are there. Now there will be some basic of the some equipment designs, the industry equipments that also taken into consideration based on the DMA DB. That is also going to be considered as a some of the your rectifications problems which are going to be tailor made, and it is going to be based on the customers. Now again, there is another examples in the ready-made garment industry, that fashion designing, that we are also going to consider. So DMA DB is a very the rapid change as far as the fashion industry is concerned. So that we are going to go for the design for the Six Sigma, different type of the fashion designing, the ready-made garments and the clothes, which are going to put an impact based on the customers varying demand and very rapid varying demand. And the some of the another examples that also we can discuss with regard to the your some comfort, this the aspect of the some comfort seating arrangements as far as the your inside seating arrangement is concerned in the four vehicle passenger cars and others, and especially the other items as far as the furniture is concerned, modular furnitures are concerned, and that is also based on the very customized demand. It is going to be made, though it is a flexible manufacturing systems are applicable, so there won't be a very rigid manufacturing system, but it is a flexible manufacturing system which is going to be used for the different considerations of the different sizing under the DM and DB. So this is all as far as the different examples are concerned. With this basis, thanks a lot for the patient listening. This is the part which we have completed as far as the design for the Six Sigma is concerned. And, so we'll continue with the next session. And then we are going to discuss another topic that is going to discuss the leveraging the Lean Six Sigma in SCM acceleration and Lean Six Sigma logistics, that we are going to discuss in the next session. And we are going to just close this session. People go from